building vision language models on solid foundations with mask distillation. Having an aligned text, image, or multimodal representation has many use cases, including zero-shot classification, image-to-text and text-to-image retrieval, image generation, visual question answering, image captioning, and many more. Prior work used paired data, so images with their corresponding captions or alt text, to train two, that is in the case of CLIP, or one encoder to align these modalities. MaskClip also shown that using self-distillation via masking is also improvement to get better representations. What is missing from prior work is the reliance on paired data. There is a lot of unpaired data with higher quality. For example, there are far fewer paired samples in languages other than English, but there is a lot of text in languages other than English. Or images with segmentation usually don't have captions, but they have rich segmentation masks. The naive approach is to use a multitask learning approach. So you have an encoder that is either seeing multimodal data or seeing unimodal data and has two or more loss terms. That is complicated, and training such a model would take significantly longer time than training just a contrastive clip-like model. So our simple approach is to use pre-trained foundation models that are unimodal and distill their knowledge into our text and image encoder on those paired data. That is the big difference from the naive approach. So in details, what we do in our approach is we start from a clip-like approach. We have the vision encoder and the text encoder. They are fed with mask samples, and we want their representations of the paired data to be close and the unpaired data to be far away. Then we add the foundation models, the unimodal teachers, to add an extra loss, an extra distillation loss on all the patches or the tokens of the text. Importantly, we only feed a subset of the mini batch to these teachers to keep the training cost low. Finally, we use the text embedding of the teacher and we just project that into the representation space of our text encoder. By doing so, even though our text encoder has never seen sentences in languages other than English, it will inherit the multilingual capability of the large language model teacher in languages other than English. We show the improvements of our method over CLIP in different common benchmarks, including zero-shot ImageNet classification, image classification in the wild, and MS-COCO image-to-text and text-to-image retrieval. In all the cases, we show great performance improvement over CLIP and other methods that combine some loss terms with CLIP. Most importantly, we gain all of these improvements with negligible extra training time compared to the CLIP. Also, we show inherited capabilities from the vision and text teachers. From the vision teacher, which is SAM, or Segment Anything Model, we get zero-shot instance segmentation by using SAM's frozen decoder on top of our frozen encoder, which shows that our representations are well aligned with the teacher. Also, we show significant improvements over the CLIP baseline on languages other than English for image-to-text retrieval. We see that the base model, the log CLIP, is basically not capable of understanding languages other than English or the languages that are really similar to English, like French. But our model is significantly better than the base model in languages that are far away from English. And we gain all of these without ever seeing paired data in languages other than English, or any data in languages other than English. So in conclusion, we introduced SF-CLIP, a method to use pre-trained unimodal foundation models to train CLIP-like models. We achieved state-of-the-art performance and zero-shot multilingual capabilities, and all of that with the same inference cost and negligible extra training cost. Thank you for listening, and you can check out our code at the following link.